Let's prove another theorem. We'll call this one Theorem 0.007, and sticking with our numbering convention. And it'll say, well, first we need to say let A, B, and C be 3 collinear points. Be 3 collinear points. I might have spelled collinear wrong there. My spelling's not very good. Then B is between A and C, and if you recall that we denote that A-B-C, if and only if, which I use IFF as shorthand for that, AB plus BC equals AC. Well, let's think about what this means before we prove it. It may look a little weird right there, but it's something that's pretty intuitive. At least I think it is. So we'll say we have 3 collinear points, A, B, and C, and we'll have a line running through them. Well, let's look at what our theorem is saying. It's saying AB, well, we have B in the middle, then AB plus BC equals AC. Well, AC is the distance here. AC, let's just say AC is a distance of 7. We'll pick 7 pretty arbitrarily. Let's look at AB. AB would be the distance right here. Let's say that's 4, and BC, we'll say that's 3. Well, it would make sense that we need AB plus BC to equal AC. If you just look at that picture, it seems like that should happen, and it turns out it does, and we can prove that. So let's go to our proof. We'll start out by saying suppose B is between A and C. So suppose A-B-C. And whenever we write this like this, since B is between A and C, they must be on the same line, so they must be collinear. And we'll say let L be the line through A, B, and C. We could have just picked 2 of those points for L to be the line through, but we'll just say all of them. Either one would have worked just fine. We'll also let f of L to the real numbers, so this is our ruler function. We'll say let that be a ruler for L. Then, since A-B-C, or since B is between A and C, we have f of A less than f of B is less than f of C. If you recall, that was just the definition that we gave for collinear points. Or we have the other alternative definition, f of C less than f of B less than f of A, which those things really say the same thing. Then suppose the first one. Suppose f of A less than f of B less than f of C. Let's make this a little bit easier to read. Put that there and 2 there. So we have 2 cases that we have to prove this for. We'll suppose the first one. Alright, and then by the ruler axiom, AB plus BC equals the absolute value of f of b minus f of a plus the absolute value of f of c minus f of b and then we'll say because of our statement, because of our assumption, this is equal to f of b minus f of a plus f of c minus f of, where was it? F of c minus f of b. Should have another set of parentheses around those, which is equal to f of c minus f of a. Then, because these are positive numbers, we say f of c minus f of a equals AC. And that is by the ruler axiom. By the ruler axiom. And then something that's, actually that's not the end of our proof. Something that's done quite a bit in proofs is, if you look at this, you can tell that the other side should just be the flip-flop of this. So something's done quite often, which is actually considered bad form, but I'm going to do it here anyways, is say part 2 is similar. And you don't ever want to say something similar unless it's really just the same exact thing with a few of the variables switched around, and it's obvious which variables would be switched around. So that's the end of proof 0.007. As long as we have 3 collinear points, the distance between the outside two is equal to the distance between each quote-unquote half of the distances.